So in case you missed anything in the first video for 1.15, you can pause the video before I move on to the next page. And we're continuing. So again, I want you to sort of recognize that this function passes the vertical line test and the horizontal line test. So it is one-to-one, and it might be beneficial for you to write this out, even though for some of you, I'm sure this is obvious, you know, that we're just writing the ordered pairs. So then when you graph the inverse of h, that you just switch x and y around, and we write it in inverse notation. So -3, -5, just switch. -3, -5, 1/2 -4. And it doesn't have to be perfect. Obviously I'm rounding, or maybe it's not obvious, but I am just approximating that value. 3, -3, and then what's the last one? 5, -1. But just like what I mentioned before, as you connect your dots, this will be a reflection over that diagonal line y equals x. And we usually put those dashed lines in there, so you know it's not part of the graph, but that there's a relationship there, and that's why we have it. Now, before jumping into any problem, please remember everything you learned in Algebra 2. For instance, as you look at this, you should already know it's shifted right, I'll just do right 3 down 2. But that's not even what I care about. What I care about is that this is a parabola. So if you were to try and graph this, this fails the horizontal line test. So f is not one-to-one, and we can say that the inverse does not exist. So something like that, and you can mention that fails the horizontal line test. Something to let me know that you understand. All right. Now this is going to get more complicated. Don't just jump and say, "Oh, this is easy. Let me start the homework." Because as we move on to g, now this is a linear function. If you want to graph it to make sure it passes, it would be shifted down 3 and the slope is up 2, right 5. Which is not a bad thing to practice, that you understand. Because you can actually use this to compare it to the inverse and see if you get the right answer. But you probably remember doing this, because remember this is y equals, etc., etc. So you switch x and y around, and then you solve for y. And you solve for y by adding 3 over. And I like multiplying by the reciprocal. So multiply both sides. I'll switch back to purple, by 5/2. And let me go ahead and distribute that 5/2 in there. So all of that cancels. Let me scroll down a little bit more. So it would be 5/2 x plus 15/2. Now instead of writing y equals, let me go ahead and write it. We typically write it in this notation of the inverse. So f inverse of x. And it's going to be written this way on a test, so get used to it. And let's go back to that graph I made earlier. In case you didn't know, 15 divided by 2 is about 7.5. So if I were to ask you to graph that, you know, you'd have a y-intercept up here, but then the slope would be up 5, right 2. Well, if I go backwards, it would be down 5, left 2. And what you'll notice is that if I drew that diagonal line, they are reflected over that diagonal line y equals x. So it does make perfect sense. Now here's the thing that I totally agree can be confusing, is the parabola that we had earlier failed the horizontal line test. So we just didn't do the problem. But then this problem is a square root function. Well, you can for sure do the square root function, this is shifted left 3, up 4, and it has this stretch of a factor of 2. Now, I'm not too worried about the stretch yet. What I would point out for you is to switch x and y. Remember, this is y equals. So if you rewrote it, it'd be x equals 2 square root of y plus 3 plus 4. So if I'm solving for y, I'm going to try and do this step by step so I don't lose anybody along the way. So subtracting 4 over. Now when you divide both sides by 2, you want to make sure you divide everything by 2. And I'm like writing this as 1/2 instead of x divided by 2. 4 divided by 2 is 2 equals the square root of y plus 3. Well, now your next step, when you square both sides, you have to be careful. Why do I say you have to be careful? Well, what's inside could only be a positive value. So, actually, maybe I'll just address this here in a second. So then we just have y plus 3. And then your last step would be to subtract 3 over. So 1/2 x minus 2 being squared minus 3. And instead of writing y equals, I hope all of you are okay that I just changed this back to what the original problem was, which was g. There we go. Finally, let me do it. And write it as g inverse of x is equal to this. Now, I said to be careful earlier because if you were to look at this graph, I think a lot of you would talk about it being shifted to right 2, down 3. The only issue is that 1/2. It is actually shifted right 4, down 3. But if you were to look at this graph that we had started with, and I asked you to reflect it over that line y equals x, we only want half of the parabola. Now, which half do we actually want? Well, let's go back to the original problem. What was the domain in the original problem? We only wanted values for x that were between starting at -3 and going infinitely to the right. Well, what about the range of that problem? Well, the range, by our rules, started up at 4 and went infinitely up. Well, now let's look at our inverse. Well, if we look at our inverse, do we have any limitations for our x value? And right now the answer is no. So that's why I told you to be careful when we had this squaring thing, because we only wanted the positive values. So we only want this piece right here to be positive numbers. And as you remember before, the range becomes the domain for the inverse. So we only want x to be 4 or larger in this problem. And that makes this piece positive, because half of 4 is 2, minus 2 is 0, squared is, well, I should say non-negative. But you have to state this, otherwise your inverse fails the horizontal line test. And I know that's weird, I get it. But remember earlier we had to say that the parabola from letter F failed the horizontal line test, so the inverse does not exist. Well, now the square root function passes the horizontal line test and vertical line test while I'm at it. So its inverse must also pass. Well, that only passes if we limit the domain, and again the range becomes the domain in this problem. I hope that makes sense. I'm totally expecting questions when I see you, or if you contact me through email, and we can set up a Google Meet if you need it. And then this is the last big thing, is the composite function. So they ask you to start by finding the inverse. So the inverse, you can just believe me that this passes the horizontal line test. So as a reminder, you switch x and y around. Multiply the 2x over, or 2 to the x, 3y minus 4. Then add 4 over. And then divide by 3. And again, I trust you guys are smart enough to realize that we can now change y to g inverse. All right. So now what you're asked to do is define g of g inverse of x. And this is the composition function. We've already learned this. So what that means is you look at the g function. Notice I just wrote the g function, but now I'm going to replace, just switch colors to make this a little bit more vibrant, switch x with the inverse. So that's 2x plus 4 all over 3. So as you're asked to simplify this, first thing is maybe you cancel out the 3's. So you're looking at now 2x plus 4 minus 4 all over 2. So then maybe your next step is to say, oh, plus 4 minus 4 will cancel. So we're left with 2x over 2. And maybe here you'd say, oh, well, that's nice. These 2's cancel. So you're just left with x. So that's what you're supposed to notice, is if you do this correctly, the composition of a function with its inverse will cancel each other out, and you'll be left with just x. And that's how you can test if things are inverses of each other. So let me write that down. This is just a test to see if you did things correctly. Do you think it'll also work if you switch them around? Well, let's try. So if you accidentally switch g inverse and g around. So g inverse is that 2 times plus 4 all over 3. And then you're going to replace the original function, that 3x minus 4 in here, all over 2. So I think the first thing you'll notice, just like before, is those 2's will cancel each other out. So you're left with 3x minus 4 plus 4 all over 3. I think you already see where I'm going with this. Those cancel. So you're left with 3x over 3. And then the 3's cancel, and you're just left with x. So is g and g inverse inverses of each other? Yes, as long as the composition function cancels everything else out, and you're left with just x. I think for the sake of time, I'm going to resort to the answer key for this last. So if you need to copy anything down from up here, go ahead and pause it. And I'm going to share the answer key with this last one because I think we are just about out of time. So again, if you're told that f and g are inverses, then the composition of each other will cancel each other out, and you'd be left with just x, and they both work. So as you look at the last example, are these functions inverses of each other? Because they look like you do the inverse of multiplication is division, the inverse of addition is subtraction. So they both look good. Part A and Part B, they look like they're legit answers. The problem with letter B, though, is if you do the composition, and it doesn't matter which one, as soon as you see one that doesn't work, then it is not, they are not inverses of each other. All the work is laid out for you. Letter A, they both work, f of g of x and g of f of x. Everything cancels and you're left with x. So they are inverses of each other, whereas letter B is not. I do want to mention, make sure that you pay close attention if they are one-to-one functions, because you could algebraically get everything to cancel, but please don't forget that if one of the functions fails the horizontal line test and there's no statement about the domain or range being limited, then they might not be inverses. So please be careful as you work through your homework.